So I'm looking at DEB 2016 Leaving Cert Higher Level Maths Paper 1, Question 4. It's a complex numbers question. The first one says z is equal to minus root 3 plus 1 is a complex number. Write z in polar form. So nice question. We know it's minus on the real axis and 1 on the imaginary axis. You can find the modulus very easily by just using the modulus formula. Or is equal to the square root of or is equal to the square root of a squared plus b squared, where a and b are coming from minus root 3 and 1. The argument's a little bit more difficult to find. We first need to find the reference angle here because it's not in the first quadrant, which is annoying. If it's not in the first quadrant, we need to find the reference angle. Just drawing out our little right angle triangle that I've gotten. I know this length is root 3 and this length is 1. Oops, go back. I'm working in radians. You can work in degrees if you want, but more often than not we work in radians. So just show your calculators in radians. Tan inverse of 1 over root 3 is 1 over 6 pi. We know it's going to be smaller. Look, that's 180 degrees, so it's going to be smaller than 180 degrees. 180 degrees is pi radians. So it's going to be pi radians minus 1 over 6 pi, which gives us 5 pi over 6. And then we write it in polar form to finish off with. Use the Moivre's theorem to find z to the power of 4, give your answer. Okay, so it's just z to the power of 4 is what we want to find. So this is pretty easy. If we know z is this, and we have to use the Moivre's theorem, we're going to put both sides to the power of 4. And then the Moivre's theorem says that it's the modulus to the power and the argument by the power. So 5 pi over 6 is the same as 20 pi over 6. Stick that into your calculator, making sure your calculator is in radians. Cos of 20 pi over 6 is minus half. Sine of 20 pi over 6 is minus root 3 over 2. We want it in a plus b form, so that's why we're multiplying it out. 16 times minus half is minus 8. 16 times minus root 3 over 2 is minus 8 over root 3. And we have the i's there, so that's that bit done. The next bit's a little bit more difficult. How many, if I was to go and go z is equal to minus 8 root 3i, I'd have to put that to the power of a quarter to find z on its own. So think power of a quarter, you generally think general polar form. And with general polar form, how many answers should you get? You should get 4 answers here because the power is a quarter. And that's not what the next question is actually asking us to do. It says using the fact that z is one of the roots or otherwise, find the other roots of z to the power of 4. So I've just drawn out a little sketch here. We've got our real axis and our imaginary axis. We've got z to the power of 4 down here as minus 8 root 3i. We know z here is minus root 3 plus 1. And what I said is all the answers, all the roots, if I'm working backwards to find the roots, we should have 4 roots. But also, if you notice, anytime you've used general polar form, the modulus of your answers are always the same. So what I'm trying to imply here is the distance, this distance, is going to be the same for all of your answers. So z, remember z in polar form, z in polar form was 2 cos, what was it, 5 pi over 6 plus I sine 5 pi over 6. And I know I want 4 answers. So this is the first one. This distance, that brown distance, is 2. And this angle here is 5 pi over 6. Okay, well I want 4 answers. So I need to go 2 pi divided by 4 is equal to half pi, or half pi radians, or 90 degrees. So basically what they're saying is the other answer is going to be here, because it's another 90 degrees. So that's what's the next answer going to be. So how big is this red angle? It's going to be the brown angle plus 90 degrees. So Z1 is equal to 2 cos 5 pi over 6 plus I sine 5 pi over 6. Z2, which is the red one, it's going to have the same modulus. It's just the argument is going to have half pi added onto it. Okay, the argument is going to have a half pi added onto it. I think that works out to be 8. So add a half pi onto 5 pi over 6, 8 pi over 6 plus I sine 8 pi over 6. Okay, then consider what the next one's going to look like. It's going to be another 90 degrees added onto that with the same modulus. So we're adding on another 90 degrees or another half pi. So Z3 is 2 cos 11 pi over 6 plus I sine 11 pi over 6. Done. And the next one is going to have another 90 degrees added onto that, but you can notice that the 90 degrees added onto it brings it back into the first quadrant. So it's Z4 is equal to 2 cos. Now imagine adding onto the 11 pi, so I'm going to type that into my calculator, 11 pi over 6 plus 0.5 pi. I'd get 7 over 3 pi. 7 over 3 pi. But I'm not going to use that 7 over 3 pi because you can see 7 over 3 is, what's the black here? 7 over 3 is that. I could just use this angle here. So how could I find that little angle if I know the big angle is 7 pi over 3? I could just take away a full circle, which would be taking away a full 2 pi. So I'm going to 7 over 3 pi minus 2 pi, and I'm getting 1 over 3 pi. 1 over 3 pi plus I sine 1 over 3 pi. And there are your 4 roots there. I don't think you have to change them to rectangular form. I think it's okay to leave them in polar form. Okay, and the last question then of it is verify that 2i is a root of the equation. Well, if it is a root, when I sub it in for z, it should multiply out to satisfy the equation, as in when I multiply it out, it should make sense. So 2i by 2i is 4i squared, 1 by 2i is 2i, 3i by 2i is 6i squared, and I haven't multiplied anything out here. Then I'm going 4i squared, well I squared is the same as minus 1, so I'm getting minus 4. Minus by 2i is minus 2i, minus by 6i squared is minus 6i squared. I notice that the 2i and the minus 2i cancel. The minus 6i squared changes to plus 6i squared, and 0 is equal to 0, so therefore z is equal to 2i is a root. Perfect. Okay, well if I know it's a root, I know that z minus 2i is a factor, and they want us to find the other roots. So how I go and find the other root is by finding the factor and then dividing it in. Okay, so z by what is z squared? Z by z, so I'm going z squared. And z by minus 2i is minus 2iz. Same thing we always do, change the signs. Okay, well this bit now looks really complicated, so I'm going to go and do a little bit of rough work. Minus 1 plus 3i times z plus 2iz. That's minus 1z minus 3iz plus 2iz. That's minus 1z minus 1iz minus 1 minus 1iz. That's what I'd get out of that. Minus 1 minus 1iz plus minus 2 plus 2i. Okay, so z by what is minus 1 minus I? Z, so plus minus 1 minus 1i. And this by this by this. Minus 1i z minus 2i by minus 1i. Just change the signs. This first one definitely goes to 0. It's the second one that I just want to just check out. Minus 2 plus 2i. Oops. Minus 1. Minus 2i plus 2i minus 1 minus I. Minus 2 plus 2i minus 2i minus 2i squared minus 2. Those two in the middle definitely cancel. We're going minus 2 by minus 1. Minus 2 plus 2 is equal to 0. So we're getting 0. So that means this is another factor. Z plus 1 minus 1i is equal to 0 as a factor. So Z is equal to minus 1 minus I. So Z is equal to 1 plus I is the other root. Bit of a nasty question at the end, those last two parts, to be honest. This part, definitely a bit nasty, and this part a little bit nasty as well. The reason you would never use the complex conjugate roots theorem here is because look at the coefficients, and this coefficient is real, but this coefficient is not real, and this constant is not real. How do I know they're not real? They have i's in them. So yeah, not a very nice question at the end, but manageable. Root.